My name is Amber Huff. I'm a research fellow at the Institute of Development Studies, and this lecture covers critical perspectives on zoonotic disease. Zoonotic disease, or zoonoses, are the leading pathway of infectious disease emergence. Zoonoses are infectious diseases that can be transmitted between wild or domesticated vertebrate animals and humans. Many of the pathogens that affect humans are zoonotic in origin, including, for example, those that cause plague, yellow fever, mumps and measles, bovine tuberculosis, rabies, SARS, some strains of influenza, Lassa fever, HIV/AIDS, and Ebola virus disease. When we're speaking of zoonoses, you might hear people speak of spillovers. A spillover is an event in which zoonotic transmission occurs between a non-human reservoir population and a human host. When a spillover occurs, a novel pathogen enters a new population of hosts and can cause isolated cases in the new host population or can cause epidemic disease. There's been a significant increase in outbreaks of zoonotic diseases over the past 40 years. People in low-income countries are disproportionately at risk of sickness or death due to these diseases. Research by Kate Jones of the Zoological Society of London shows that globally, more than 60% of all human diseases and around 75% of emerging infectious diseases over the last few decades have been zoonotic. Zoonotic diseases have a high overall impact on human health, animal health, and hence livelihoods and ecosystems, and are a pressing concern for international development as they account for 20% of human sicknesses and deaths in least developed countries. Often undermeasured and underprioritized in policy, if unchecked, they create both current problems for already poor people and dangerous future threats for us all. Many major global public health problems are caused by what are referred to as old zoonoses, for example, HIV/AIDS and malaria, with a long natural history, but that have jumped from animals and now transmit person to person. In recent years, global and national level policy has begun to emphasize the importance of once neglected zoonoses and the challenge of new and emerging zoonoses, and as a result, there is a massive demand for integrated approaches to human and veterinary health. But huge gaps in both the evidence base to inform these and funding to make them work in poor settings is lacking. Over 3/4 of emerging infectious diseases in the past few decades are zoonotic. The majority of these have been documented in relatively rich countries with functioning health surveillance systems and extensive public health coverage. This highlights that emerging infections are not something sneaking up on privileged settings from lower income settings, which is a pervasive stereotype, but that they are truly a global health problem. It also highlights possible threats and areas of global health neglect and shortcoming in disease surveillance. Some zoonotic disease events result in disease outbreaks with global attention that hit the headlines and affect centers of power. Others emerge in particular areas and remain relatively local in their extent. Zoonotic infections are a pressing concern for international development, as they account for 20% of human sicknesses and death in least developed countries, as we said previously. What a map like this cannot demonstrate is that often zoonotic disease emergence events relate to patterns of endemic and epidemic disease in localities that do not receive high-profile media attention, as they quietly decimate people's lives and livelihoods. According to the World Health Organization, the impact of neglected zoonotic diseases on health services and economies is most severe on poor households in developing countries as well, as most populations living in rural areas are still largely dependent on animals for feed, transport, and farm work. Populations from peri-urban areas are also affected. Zoonotic diseases are underdiagnosed, particularly among poor people, and this underdiagnosis reflects the limited capacity and coverage of health services. People who are poor are less likely to be correctly diagnosed and treated against neglected zoonotic diseases. There are different ways of categorizing zoonotic diseases. One of these is on the basis of temporality. Endemic zoonoses are present in many places and affect many people and animals at a relatively constant rate. Examples include brucellosis, leptospirosis, and salmonellosis. Outbreak or epidemic zoonoses are sporadic in temporal and spatial distributions. Examples include Ebola, anthrax, rabies, and Rift Valley fever. These infections flare up quickly in localized areas. Emerging zoonoses newly appear in a population or have existed previously but are rapidly increasing in incidence or geographic range. Many occur or are first noticed as outbreaks. A good historical example is the HIV virus. More recent examples include SARS, Henipaviruses, and new strains of influenza. Another way of classifying zoonoses is based on the type of host and transmission. Livestock people zoonoses are transmitted directly from domesticated animals to humans. For example, H5N1 and other swine flu strains and Rift Valley fever. Zoonotic infections can also be transmitted indirectly between livestock and people through an intermediate insect vector, for example, trypanosomiasis. Wildlife people zoonoses are transmitted directly from wild animals to humans. Examples of these include Nipah virus, Ebola virus, and Lassa fever. Intermediate and secondary hosts can often amplify transmission. These would include things like apes and Ebola, Hendra virus in horses. A good example of this is the outbreak of Nipah virus in peninsular Malaysia in 1999, when intensive pig farming began on the habitat of infected fruit bats. Unidentified infection of pigs amplified the force of infection and eventually transmitting the virus to farmers and causing 105 human deaths. Zoonotic transmission can occur any time that different species of animals, including humans, come into contact. This chart demonstrates zoonoses that commonly occur among wild animals, domesticated animals, and humans. Still another way of classifying zoonoses is based on public interest and policy impact. High impact and interest zoonoses are headline-hitting and often evoke major political and public fear. For example, recent pandemic flu threats and Ebola infections spreading from West Africa to Europe and North America. These are most often those that are seen to pose threats to the centers of wealth and power, like SARS and swine flu. Low impact and interest zoonoses most often go unremarked outside of the geographic area directly affected, or have a large impact on health globally but receive little attention or focus from media. These are those that more quietly devastate lives and livelihoods and have a dramatic impact, particularly on poor people and in poorer places. Policy, investment, attention, and media focus disproportionately on the former. Zoonoses with the most impact on poorer people are often considered neglected tropical diseases with low research and low funding priority that tend to cluster in tropical regions of the world. Except for the newly emerging zoonoses such as SARS, highly pathogenic avian influenza, and more recently Ebola virus, the vast majority are not prioritized by health systems at national and international levels and are therefore labeled as neglected. Understanding the dynamics of zoonosis requires a focus on human ecological relationships. Published examples of zoonotic disease emergence demonstrate this, as they are associated with things like habitat fragmentation and reduced biodiversity, increased human density, and agriculture in wild ecosystems, the intensification of livestock production, especially in proximity to wildlife habitats. These have all created opportunities for spillover and amplification of emerging human pathogens. But these processes are driven by wider demographic, environmental, social, and political economic change. The intensity and scale of these changes is much greater today than in previous eras due to social, economic, and environmental factors associated with economic globalization, rapid urbanization, and global climate change. This has great epidemiological and policy significance for the future, and available research and policies do not adequately address the complexity of environmental, biological, and social dimensions of zoonosis. This limits effective management of zoonotic disease risk around the world. Another way of classifying zoonoses is associated with these dynamics, whether one is speaking of spillover, the point at which a pathogen crosses from one species host into a host in a population belonging to a different species, or one is speaking of the conditions subsequent to spillover that facilitate the emergence of an epidemic in the new host population. Thinking about conditions of spillover requires deep consideration of human ecological relationships, including changing human-environment interactions and the biological processes that affect spillover, including mode of transmission, level of virulence, host immune function, and prior health, as well as the historical and social and political processes that bring humans and non-human hosts together to enable transmission. In contrast, thinking about conditions subsequent to spillover requires a deep consideration of social, economic, institutional, and political dimensions and context of epidemic disease. As stated in the introduction to this lecture, a spillover is an event in which zoonotic transmission occurs between a non-human reservoir population and a human. When a spillover occurs, the novel pathogen enters a new population of hosts and can cause a flare-up of disease cases or a disease epidemic. The impact of neglected zoonotic diseases on health services and economies is most severe on poor households in developing countries. Understanding how and why a spillover event can result in widespread human and animal illness often requires different methods and tools than understanding spillovers themselves. This is because a spillover in and of itself doesn't cause an epidemic. As with other types of infectious diseases, different factors are at play in different contexts, and understanding how these factors interact with the human body in different times and places is key to a more nuanced understanding of population health in the age of zoonoses.